All right. So today we get into the unit circle, sometimes called the trig circle. What is a unit circle used for? Well, it helps us easily calculate cosine, sine, and tangent. We know it as SOHCAHTOA of any angle between 0 degrees and 360 degrees. Now, in the last video, we learned about radians. Okay, so we're going to go ahead and start with the circle here on the x-axis. And by the way, I went ahead and put a link here so you guys could download and print this if you want to. Otherwise, you're going to do it by hand like me, okay? So I'm going to go ahead and draw a circle, and I should have drawn the circle first, okay? So let me go ahead and draw it again. So I'm going to go ahead and draw the circle again. Okay, it's not bad. And then I'm going to go ahead and draw my x and on my y-axis right in the center here of the circle, okay? And so this is going to be the origin. Okay, and what we're going to start off first with is the first quadrant, okay? And so notice here, we're going to go ahead and point out the most common angles, which will be 30 degrees, 45 degrees, and 60 degrees, okay? So of course, we have the angles on the quadrant that would be considered the quadrantal angles. So we have 0 degrees here, and then let's point out 90 degrees there, and then we have 180 degrees. And then this is going to be 270 degrees. And then if I go all the way around and come back to where I started, right? I am at 360 degrees. In other words, one full turn is 360 degrees. Okay? Now, each quadrant, right? We have first quadrant, second quadrant, third quadrant, and the fourth quadrant. Each quadrant will have 3 angles that we also calculate, okay? So it's going to be at 30 degrees. So right here, if I were to go about that high, it would be at 30 degrees. And then if I were to go halfway, half of 90, of course, is 45 degrees. And then if I were to go 30 degrees from 30 degrees, that would be 30 plus 30. That would leave me at 60 degrees, okay? And so these 3 points are the markings for the 3 angles that we're going to have in every quadrant, okay? So if I just keep going around, I'm going to go ahead and put 3 points. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? So each quadrant will have the quadrantal angles, right? The ones right on the axis. And then we're going to have 3 angles in between. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? And all these in every quadrant, they're basically going to be spaced out the same amount of degrees apart. So this is 30 degrees apart, okay? From here to here, it's 15 degrees. So let me just go ahead and label this here. This is 15 degrees from there to there. This is 15 degrees from there to there. From here to here, it's 30 degrees. And then from here to here, it's 30 degrees, okay? So in other words, that's just how many degrees there are in between the other angle and this one here, okay? And so notice here, from here to here, it's going to be the same thing, 90 plus 30. Feel free to use your calculator. 90 plus 30 is going to be 120. Okay? And then, let's see, let's do 120 plus 15. That's going to be 135. Add another 15, you're going to be at 150. Or you could just say, oh, there's 2 15s here between the 30 and the 60. So this would just be 15 and 15, another 30. 120 plus 30 is 150. And notice we have 180. That's 30 degrees from there. Another 30 degrees, that's going to be 210 degrees. And then we have 225. Okay, use a calculator, that's fine. 240 degrees here, and then 270. Notice, plus 30. 270 plus 30 is going to be 300 degrees. Oops. And then we have 315. And then we have 330. And then we have 360 degrees. Okay, so we went all the way around the circle in degrees. Now, the other day you went ahead and did a converting to radians, right? So we converted to radians, all the degrees. And so what we're going to do here is we're going to do the same thing. Again, we're just going to convert to radians here. Okay, so to convert to radian, I got to multiply by pi over 180. So I'm just going to do this on the calculator. 30 times pi over 180 is going to be 30 over 180. And I get 1/6. So this will actually be pi over 6. Okay. If I were to do the 45, it would be 45 over 180. And then just add pi later. Notice this will be pi over 4. Okay? And then 60 degrees will be 60 over 180. And then this will be pi over 3. Okay? What about 90? It'd just be 90 over 180. Oops, 90 over 180. And I get pi over 2. Okay? By the way, 0 over 180 would just be 0, so it'd just be 0 pi there, okay? So in other words, just 0. Let's go around. 120 degrees. 120 over 180. Use the fraction key. Is going to be 2 pi over 3. Again, we're doing it in radians here, okay? 135 degrees, that'll be 135 over 180. We get 3 pi over 4. And then all around the circle, okay? So 150 over 180. Reduce it, I get 5 pi over 6. Now, if you're wondering where am I getting the pi from, remember you got to go back to the earlier lesson, the last video that we did. We talked about how to convert from degrees to radians, okay? And we have 180 over 180. Well, that's just going to be 1 pi, or just pi. Okay, almost done. I got to do the bottom half of the circle here. So we have 210 over 180. These are improper fractions. Notice I get a mixed number, so I'm going to just change it to, oops, I need to hit the second key, so it'll be 7 pi over 6. Let's do 225 over 180. Another improper. I'm sorry, mixed, so I'm going to make it improper. That'll be 5 pi over 4. And so you see how helpful it is just to have the calculator. So we have 240 now over 180. That's going to be 4 pi over 3. Let's do 270 now. 270 over 180 is 3 pi over 2. 300 over 180 is going to be 5 pi over 3. Okay, let's do 315, 2 more to go. 315 over 180 is going to be 7 pi over 4. And then finally we have 330. Actually, we have 2 more to go, right? The 363. 30 over 180 is going to be 11 pi over 6. And then 360 over 180 is going to be 2 pi. Okay? So there is the completed circle in radians and degrees. So degrees are first and then the radians come next. It doesn't matter the order, but you have them there. So now notice here, if I ask you, what is 60 degrees in radians? Oh, you could just look at this unit circle. It's pi over 3. By the way, let me erase these angles inside because I don't want you guys to get confused with those extra numbers there. Okay? So we're only interested in the degrees and then the radians right now. Okay, so notice here we have 30 degrees is pi over 6. 240 degrees is 4 pi over 3. So this is a nice tool that we can use to quickly convert from radians to degrees or degrees to radians. Okay, so now here's what I want you guys to do. I want you to go ahead and get a blank unit circle. Okay, and then just go ahead and fill in the angles in radians and degrees. Notice here inside the unit circle, I have 2 empty spaces here. Okay, if you can print this out, that's cool. If not, just go ahead and draw it on blank paper like I did a moment ago. Okay, now outside here we have coordinates. You'll see a little comma there in parentheses. That's going to be for a future lesson. Okay, right now we're only interested in degrees and radians. So let's go ahead and start here. Notice here this one has 2 of them because we're going all the way around the circle. So I'll just start with here, 0 radians and 0 degrees. Okay, so 0 degrees, 0 radians. So I could just go ahead and do all the degrees first. So this will be 30, 45, 60, 90, 120, and use your calculator if you have to, 135, 150, 180. That's 210, 225, 240, 270, 300, 315, and 330. And then up here, it'll be 360, okay? Now, I want you guys to notice here, if you just were to drop the zeros on all of these, they're the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, right? If you were to drop the zeros, not the ones with the 5s, just the one with the zeros, right? They're multiples of 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and so on. All the way around the circle, notice 3 times 10, 3 times 11, and 3 times 12. So that's really all the ones that have the zeros on them. It's really 3 times 10, 3 times 20, 3 times 30, and so on. Okay? The ones in between here, they're just really 45 degrees, 45 multiples of 45. So notice here, this one's 45, and we have 45 times 2 is 90. 45 times 3 is 135. 45 times 4 is 180. And then we have 45 times 5 is 225, 6, 7, 8, okay? So that's all I want you guys to do today. Just go ahead and practice filling in the unit circle in the degrees and radians. So now right here, let's do this one here. So this is, well, I'll actually teach you guys a shortcut now, okay? Let's go ahead and let's do pi over 6 here, pi over 4, pi over 3, okay? Now, here's what I want you guys to see here. All the ones here that are at the 30 degrees, if you go straight across like this, right? If you go straight across, this one will be the lowest one, right? So if you go here, we have a low, medium, and tall, or short, medium, tall. So the short one on this side here is going to be the same. It's going to be pi over 6. The medium one across from it will be the same. It'll be pi over 4. The tall one here across will be the same. It'll be pi over 3. Now, there's going to be some numbers on top, but we'll get to that in a moment, okay? Now, let's go this way here. This one's the short one, right? So we're going to go down to the first one here. That's the short one also. That's going to be pi over 6. Then the medium one, that's going to be this one here. That's going to be pi over 4. And then the tall one here is going to be the tall one down here. That's going to be pi over 3. Okay, then I could go across like this again. So this will be pi over 6. This will be pi over 4. And this will be pi over 3. Okay, and we left these blank, right? And the ones on the quadrants, so we'll get to those at the end. Now, watch this here. When we go across here, these are going to be 1 less than the denominator, okay? If you notice here, 2, 3, 3, 4, 5, 6, okay? So we go here, we can help us remember on the second quadrant, these are going to be 1 less. So that'll be 2, 3, and 5. In other words, 1 less than the denominator. So 5 over 6, 3 over 4, 2 over 3. And that's it for that one. For these here, let's see. Let's look at our pattern right here. Notice these are 1 more. So 6, 7, 4, 5, 3, 4. So the numerator is larger. So here we just count 1 more. So that'll be 7, this will be 5, and this will be 2. Okay? And finally, these here, these are a little different. Notice here. There's no nice pattern here. I do see that they're all odd, 5, 7, and 11. Okay? One way you could remember is just by looking at the one across from it. Notice this line, if I travel to the other pi over 3 here above, if I add those two, 2 plus 3 is 5. Okay? If I go to the pi over 4 here, 4 plus 3 is 7. And then right here we have 6 plus 5 is 11. Okay? One way to remember this is just think 7, 11. So 5, 7, 11. Okay? Just, we already have 3. And then the next odd number is 5. And then the next one is 7. Just think 7, 11 like the convenience store. Okay? So 3, 5, 7, 11. Now what about these on the quadrants? Well, this one at 90 is going to be pi over 2. So this goes pi over 6, pi over 4, pi over 3, and pi over 2. The one right below it is also going to be pi over 2. But then we're going to add these two. 2 plus 1 is 3. So this will be 3 pi over 2. Okay, if you remember, we did that on the one before. Okay, and then 180 is always going to be pi. Okay, and over here is always going to be 2 pi. Okay, so that's it. So go ahead and try this with another blank one. Okay, do it at least 2 times. Do it at least 2 times on your own, just to get the hang of it. Okay.